The chapter is very important. Mostly will get 3 marks question on this. An easy chapter where you have to understand and wordings you can create of your own. That is the advantage of this chapter. So Sakshi, since we were absent last time, so I'm just revising something.
Okay, sir.
What do you mean by alternating voltage or alternating current? The current or voltage which changes its sign after every half cycle is called as alternating current or alternating voltage. That means for half time it becomes positive, another half negative, positive, negative. This is called AC voltage or AC current. When it is made to pass through some device and you get output only in one direction, either all positive or all negative, then that device is called as rectifier. So device which can convert alternating voltage or alternating current into direct voltage or direct current is called rectifier. The process is called as rectification. Have you heard about P-type semiconductor? First, P-type semiconductor is pure or impure semiconductor? P-type semiconductor is pure or impure semiconductor?
Pure. Pure.
This is called impure semiconductor, which is added with impurity in germanium crystal. Germanium is pure. उसके अंदर फिर ऐड कर दिया एल्यूमिनियम और गैलियम और बोरॉन, तो पी टाइप का सेमीकंडक्टर मिला. इसको बोलते हैं एक्सट्रिंसिक. प्योर नहीं होता है, वो इम्प्योर होता है. इसके अंदर मेजॉरिटी कैरियर पॉजिटिव होल होते हैं, मतलब इलेक्ट्रॉन कम होता है, पॉजिटिव होल ज्यादा होता है. मतलब डेफिशिएंसी ऑफ इलेक्ट्रॉन बहुत रहता है इसमें. देन इस एन टाइप सेमीकंडक्टर. So pure germanium crystal, if I take, then they are forming valence covalent bond with the neighboring atoms. So they do not have anything more or less. Whatever they have equal number, because you are not adding anything from outside. So if it's bond break, I get one electron outside, then एक electron इधर कम हो गया, उसको बोलते हैं positive होल, उसको बोलते हैं pure. But if I add something from outside, from fifth group of periodic table वाला impurity अगर डाल दिया, such as antimony, arsenic, phosphorus, they contain 5 electron in the outermost orbit. So 4 will form valence bond, 1 excess electron I will have for conductivity. मतलब इसके पास ज्यादा majority carrier में इलेक्ट्रॉन है और कम में पॉजिटिव होल है. कम में पॉजिटिव होल है मतलब if some bond breaks, तो इसका नेगेटिव ऑलरेडी वो एक्स्ट्रा एडेड इलेक्ट्रॉन के साथ ऐड होएगा, तो इसलिए वो इलेक्ट्रॉन ज्यादा होगा. तो इसको हम लोग बोलते हैं एक P और एक N. P means doped with impurity from third group, has excess positive hole. N means doped from fifth group, has majority carrier negative electron. So when P-type semiconductor and N-type semiconductor are joined together, then this boundary is called as PN junction. In unbiased state means when no battery is connected, due to high concentration of charge near the junction, the positive holes and negative electron, they diffuse. That means they neutralize each other and forms immobile ion. So P loses positive hole, hence we say it is negatively charged. and N loses negative electron, we say it is positively charged. Thus, potential developed at the junction due to this losing of positive and negative is called barrier potential. And layer obtained is called as depletion layer. Now, for germanium, barrier potential is found as 0.3 volt and for silicon 0.7 volt. So for common sense, remember this entire junction diode is like resistance only, which will take 0.3 volt उसके लिए if germanium का it is made up of or 0.7 if it is made up of silicon. मतलब ये पूरा चीज actually resistance जैसा ही है. It will oppose the flow of current. So we require battery. But it can be controlled by small voltages. Therefore, we are using this principle in electronic industry. Then I explained you what is meaning of forward biasing. Forward biasing or forward biased PN junction. What is meaning of this? So, working of forward biased PN junction is 11th standard topic. थोड़ा समझा देता हूँ. इसके ऊपर ही अपना rectifier वर्क करता है. Last class also we had done. When P side is connected to positive terminal of battery and N side is connected to negative terminal of the battery, then this junction is called forward biased PN junction. Now we will see what happens during this forward biasing. The positive terminal supplies positive volt to P side and negative terminal supplies negative electron to N side. Hence, P, which was negative, will get positive charge, and finally becomes 0. N, which was positive, will get negative electron, finally becomes 0. Hence, barrier potential becomes 0, depletion layer vanishes, and charges starts crossing the junction. And current flows through the circuit from positive terminal to the negative terminal of the battery. This is called forward biased PN junction. So in forward biased, charges diffuse, resistance is negligible, current flows, and junction diode conducts. Conduction means allows the current. So it is behaving like closed circuit. But when P is connected to the negative terminal and N is connected to the positive terminal of the battery, then N side will pull the positive hole and positive terminal will pull the negative electron. This is called drifting. So negative terminal drifts out positive hole, positive terminal drifts out negative electron. Thus barrier potential increases, depletion layer widens, charges do not cross the junction, hence current does not flow. This is called reverse biased PN junction. It is like open circuit. Open circuit मतलब एक wire कट गया ऐसा, no current flows. One minute. Then we are starting with rectifier. Attendance once I am taking. I'm just taking photo. At the end also I will take photo of this to check कि किसका किसका पेट्रोल भरा है गाड़ी में और उड़ जाते थे. Vedan, you can hear me? Vedan? Neither your speaker, nothing is there. You have just connected. Anushka, morning lecture, at the end you were not there. At the end also I will take photo, and if you are not there I will send the message to your parents, which actually I don't like, because I feel study should be done individually, not by somebody's force. This is the worst part in my life which I don't like, to keep the record. Now we'll see what is rectifier, then half wave rectifier, full wave rectifier, and then different types of junction diode. Rectifier which I have explained you, don't write, huh? Just listen. Then half wave rectifier का वो diagram के बाद से will start writing. A device which can convert AC voltage into DC voltage. A device which can convert alternating voltage into direct voltage is called as rectifier. The process is called as rectification. There are two types of rectifier: half wave rectifier and full wave rectifier. So half wave rectifier, its diagram, working, and input output waveform. Now we are going to study. See here, diagram once again. The alternating source which is to be rectified is connected across primary terminal P1 P2 of step down transformer. Step down transformer we take because this voltage is 230 volt ka supply, but we want to reduce it to nearly 10 volt. Otherwise electronic circuit, they will get damaged due to excessive heating. So we use step down transformer because from the mains voltage received is same everywhere. We have to increase decrease by using transformer as per requirement. So alternating source which is to be rectified is connected across primary terminal P1 P2 of step down transformer. Secondary terminal S1 is connected to P side of junction diode D. S2 is connected to N side through load resistance RL, across which output is to be obtained. Load resistance matlab it can be fan, it can be AC, it can be refrigerator. मतलब अपना output जिसको देना है वो device, उसको हम बोलते हैं load resistance. Now working. Now all of you will write along with my explanation. And those who have not done this diagram, they can draw this diagram first. I'm just halting for 2 minutes. So those who have joined today and were not present in last class, heading right half wave rectifier and just draw this diagram. Because your state board ka idhar se start is. CBSE board right from beginning. Just 2 minutes I'm waiting so that those who have joined today were absent for last class could draw it fast. Now write the alternating source which is to be rectified, the alternating source which is to be rectified is connected across primary terminals P1, P2 of step down transformer. Primary terminals P1, P2 of step down transformer. The secondary terminal is connected to the P side of junction. Secondary terminal S1 is connected to P side of junction diode D. Junction diode D. S2 is connected to the N side. S2 is connected to the N side through load resistance RL, through load resistance RL, through load resistance RL, across which output is to be obtained. So with this we have explained actually circuit diagram. Written full, can I remove everything?
So 1 second.
Done.
Yeah.
Right, next paragraph. See, we have now explained so far circuit diagram. Now actually I am doing working. When S1 is positive with respect to S2, then junction diode D becomes forward biased. ये मनस्वी को पूछा था लगता है लास्ट टाइम. मनस्वी,
हाँ सर.
अरे रिमेम्बरिंग, यही आपको पूछा था मैंने.
हाँ.
So S1 is positive with respect to S2, then junction diode D becomes forward biased. Forward biased means it will conduct, na? Yes, करो. Forward biased मतलब closed circuit क्या open circuit?
Open
Closed circuit.
Closed circuit मतलब करंट पास करेगा क्या नहीं करेगा?
करेगा.
करेगा. ये सब याद रखो, छोटा छोटा पॉइंट है. So when S1 is positive with respect to S2, junction diode D becomes forward biased. Hence conducts current. through load resistance RL. Current through load resistance RL from A to B. वो डायग्राम में ऊपर A बना देना, नीचे B, which last lecture I had drawn. From A to B. Load resistance RL from A to B. When S1 is negative with respect to S2, then junction diode D becomes reverse biased. Hence, diode does not conducts current through load resistance RL. Thus, it is seen that current flows. Through load resistance. Current flows through load resistance only.
So can you go back for 1 second?
What you have written?
The junction diode becomes reverse bias.
And does not conduct current through load resistance.
Okay.
Because I am not changing the screen now. So because once I write, then second part will get deleted. अभी screen change करके लिखता हूँ. Does not conduct current through load resistance RL. Thus, it is seen that current flows through load resistance RL only for positive half cycle of input. Thus, half wave rectification is obtained. The input and output waveforms are as shown in the figure. So those who have not drawn that figure, please draw. Others, no need, because already last lecture we have drawn. So this is input, which is alternating source in primary. This is output voltage, which is load resistance across voltage across load resistance. Positive ke liye there is output, negative there is no. This is called input voltage and this is called output voltage. Completed full? Is completed full now?
Yes, sir.
Next heading, right? Explain working of full wave rectifier. So in exam, sometimes they will ask for 2 marks. Draw neat level diagram for full wave rectifier, and with working diagram, then it will be 4 marks topic. Explain working of full wave rectifier. The alternating source, that means AC, which we have to make it DC. Now here you want output for both the wave. So alternating source, which is to be rectified, is connected across primary terminal. I am giving the name AB because 2 junction diode I have to use. तो दोनों का P side को P1 P2 बोल देंगे. The alternating source which is to be rectified is connected across primary terminal AB of center tapped step down transformer. Meaning I am explaining. What is meaning of center tap? Step down, we all know output voltage across secondary will be less. Now center tap means what? Imagine this is resistance. Here voltage is 10, here voltage is 6. So current will flow from 10 volt to 6 volt, high to low. Hello? Hello?
Yes, sir.
Current will flow from A to B, that is high to low. Now voltage across this will be 4 volt, huh? Because 10 either 6 either तो 4 ये resistance ने खा लिया ना by Ohm's law, V equal to IR. Any doubt? Hello? Any doubt in this?
No, sir.
No. अभी इसका बीच में ना मैं एक वायर ऐसा कर देता हूँ. Here I connect one voltmeter exactly at center. So this will record 2 and even this will record 2. So 2 volt, 2 volt. So at center tapping, exactly output voltage is here half. So what center tap does, it splits the voltage into half of voltage. So if AB is having voltage of 230, this S1, S2 will produce 10 volt क्योंकि स्टेप डाउन हो गया. इधर मैंने सेंटर कनेक्ट किया तो इसका अक्रॉस में 5 वोल्ट, इसका अक्रॉस में 5 वोल्ट. तो एडवांटेज ऑफ सेंटर टैपिंग इज इट स्प्लिट्स द वोल्टेज इनटू 2 इक्वल हाफ. ओके, फिर से एक बार अभी इधर का. The alternating source which is to be rectified is connected across primary terminal AB of center tap step down transformer. The secondary terminal S1 and S2 are connected to junction diodes D1 and D2. Connected to P1, P2 of junction diode D1, D2. N1, N2 are joined together and their common point E is connected to the center tap C through load resistance RL, across which output is obtained. This much followed diagram part? Follow
Yes, sir.
diagram. पहले डायग्राम बना लो आप लोग पूरा, क्योंकि वर्किंग के लिए मुझे थोड़ा सा एक साइड कट करके समझाना पड़ेगा. जस्ट ड्रॉ द डायग्राम. S1 S2 both are joined to P, then N are joined together, common point is connected to center tap, इसको बोलते हैं jumping of wire. Suppose I call this as F, this as G, ये करंट का डायरेक्शन होगा, कैसा मैं समझाता हूँ. Yes, completed na full diagram. Once you complete, tell.
So what is that under the resistor? What's that symbol?
RL, R suffix L.
No, under that.
Under that negative sign.
And under that.
G, G, F, G, E, F, G.
Okay.
Is done, so that we can see the working.
Yeah.
Now see, when this is positive, then this is negative, and due to mirror image, this is minus, this is plus. So this is half voltage plus minus, this is half voltage. So when F1 is positive, this will become forward biased, and current will flow through S1, P1, N1, E, F, G, back to C and S1. So during this cycle, this part is not there. So current starts from P1, goes to N1, goes to E, then F, then to G, from here C, S1. ये वाला कुछ काम नहीं कर रहा है वो टाइम पे. But when S1 is negative, this becomes negative.
So what about the output for positive S1?
When S, who is what you are saying? What about positive one?
So in this cycle, what happens to the output?
Output is across this, no, going from F to G.
Okay.
When S2 is positive and S1 is negative, then junction diode D2 becomes forward biased and conducts the current like this. S2, P2, N2, E, F, same path. G, C, and back to S2. During this cycle, this one is not conducting. This is not there. So this way we get current and output remains same. Thus we see that output is obtained for both half cycle of input and in same direction. Therefore it is called full wave rectification. Okay. Any doubt now?
No, sir.
Right. The alternating source which is to be rectified, the alternating source which is to be rectified is connected across primary terminals AB of step down center tap transformer. Step down center tap transformer. The secondary terminals S1, S2 are connected to P sides of junction diode D1, D2 respectively. Junction diodes D1, D2 respectively. The N sides are joined together and their common point E is connected to C through load resistance RL across which output is to be obtained. Circuit we have explained, working part. When S1 is positive with respect to S2, then junction diode D1 becomes forward biased and conducts current from P1, N1, E, P1, N1, E, F, G, C, S1 back to P1. P1, N1, E, F, G, C, S1, P1. During this cycle, D2 is reverse biased, hence do not conducts. When S1 is, when S2 is positive, with respect to S1, then junction diode D2 becomes forward biased. Then junction diode D2 becomes forward biased and conducts current through P2, N2, E, F, G, C, S2, P. During this cycle, junction diode D1 does not conduct. Thus, it is seen that current flows. Thus, it is seen that current flows through load resistance RL current flows through load resistance RL for both the half cycles, of input. Current flows through load resistance RL for both half cycles of input. thus full wave rectification is obtained. Thus full wave rectification is obtained. The output and input waveforms are as shown in the figure. Input-output waveforms are as shown in the figure. Draw this diagram. See, the second figure I have written plus minus doesn't mean second is minus. This indicates we are getting output in same direction for negative cycle. So first one positive, third one positive, second fourth का negative के लिए हमको वही cycle मिला. So 2 cycle is for positive and 2 cycle is for negative. Yes, draw the diagram. Hello.
Yeah, sir, done.
So we did half wave rectifier, full wave rectification, and then